Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Welcome, everybody, to today's episode of Pepperl+Fuchs Plugged In. And today, I'm happy to say I have Sean Bauman with me. Hi, Sean.
Hi, Helga. Pleasure to be here.
Great. Sean, tell us what device, what product, what exciting product, I should say, are we talking about today?
So today I'm happy to be speaking about our new IO-Link double sheet sensor within the Ultrasonic family.
All right. Two words that pique my interest right away. Double sheet sensor and then, of course, IO-Link. So what is a double sheet sensor, or rather, why is a double sheet sensor important for our customers?
So within some industries, there's the possibility of a multi-layer feed of materials. It could be paper, cardboard, metal, film, labels, etc. But if there's a multi-layer, it could potentially lead to downtime, process faults, even material waste in a lot of cases. So with the ultrasonic double sheet, they were developed really to monitor and detect double material in order to prevent faulty material feed, while also ensuring reliable processes and high ability of the machines.
Okay, so you mentioned paper. Let me tell you what's going through my head. I'm assembling a book. I need to print pages, and I certainly don't want my printing press to pull in two pieces, one of which remains unprinted. That would not be good, right? An empty page in a book is not what you want.
Absolutely, correct.
Okay, so that's what they're used for.
That is also possible. Yeah, you could detect, there are three current output stages. You could detect air, which in your example, you would not want the air output just because...
Because that means I have no paper
Correct.
that I'm drawing into my press.
That is correct. That is correct. And then you have your one sheet, which would be the ideal case for the paper going through the print press. And then there's also the case that I alluded to earlier with double material, where there's two pages overlapped on top of each other, which you also would not want.
Okay. We don't want to give the impression that this is only for paper, only when you're printing books. What are the applications for such a sensor?
Yeah, so this particular sensor, we have two models, an 18 millimeter and also a 30 millimeter that we've condensed down from a number of different models within those sizes. But essentially we have the 18 and 30, and they could work with almost any kind of material. We're talking about papers, cardboards, plastics, metal sheets, even in some cases. Also with wooden boards and glass panes as well are also possible.
Okay, so wide range of material. We're going to get back to one thing, and the one thing we're going to get back to is the product range that we used to have for a good long while. But before we go there, let's talk about a few cases where a double sheet sensor is maybe not such a good solution.
Yeah, so there are some cases when you're dealing with some metals and sheets of metals, sometimes there can be a layer of oil or grease between the two sheets. If that's ever the case, or if it's heavy, these IO-Link double sheets or any double sheet will not be able to function. There needs to be a clear space of air in between the materials. Also, for thicker materials, especially once we're talking about wood and again metals, if you have a material that's, for example, an inch thick, that is much too thick for the ultrasonic sound to propagate through the material, it would also experience issues.
Makes sense. Too thick is not good, but anything else, down to really thin, this sensor can deal with.
Exactly.
Now go back to where we came from. What was our offering for the last, 15 years or so, and what is the main change going to an IO-Link version of this technology?
Sure. So in years past, we did our best to create models that fit a general range of applications. So we had a large number of different model numbers, each with slightly different threshold settings for what told the sensor to be a single, double sheet, or air. And also we had different frequency ranges. And what we did with that was we consolidated the frequency ranges down to now one frequency within the 18 millimeter and also the 30 millimeter band sensors rather. And instead of having all of the different threshold settings, with the IO-Link introduction, you're able to fix the thresholds yourself to fit your material exactly. So instead of having us do it from the production side, the user can now have the flexibility to adjust to any of their material from their side.
And there's some software that we offer that does a very nice job in visualizing these types of settings and really helps an engineer to tweak the system to its absolute best performance.
Yeah, Pactware is a universal tool that we use for all of our IO-Link devices. It is no exception for these IO-Link double sheet sensors. And it graphically displays the threshold and the signal strength of the sensor so that user can see within real time how much of the sound beam is their material blocking. And they can adjust around that to fix the appropriate settings to whatever material they're using.
Okay, good. Now let's talk about some features of this sensor and some features that make installation simpler. And I'm thinking about scenarios where you may have a few of those mounted next to each other, or very close to each other, in fact.
Yeah. So in some cases, let me take one step back and explain why you might want to have multiple sensors mounted next to each other. So in some cases, if you want to monitor the entire web of a material, you may need to create almost a curtain of sound. And so in this case, you would mount up to about 10 sensors, and they're able to automatically synchronize between each of the sensors via a synchronization pin, or you can also synchronize through IO-Link, either externally or, again, through IO-Link.
Okay. So by going to IO-Link, is it fair to say that we reduced the complexity of the line and gave engineers the ability to use them in a wider range of applications?
Absolutely. Yeah. And I mean, especially nowadays, being able to consolidate a line and also from our end, consolidate production and stocking, from a customer side, they only have to order one or two model numbers. From our side, we only have to stock one or two model numbers. And so it helps a lot better in terms of availability and planning for production and other things from our side.
Yeah. Right now, of course, with the semiconductor shortage, not guessing what would be the right model is, of course, advantageous. I mean, not that coming up with this design helps us in fixing the semiconductor shortage, but for sure, when we built one, it's the right one.
Absolutely. Yeah. Now there's simply just higher flexibility within each device. Again, there are selectable threshold sets. There's also a teach-in threshold set via IO-Link. And then also, I didn't mention it earlier, but with the IO-Link, the user also has access to all of the parameters. And this helps them obtain insights into the device, the threshold values, the measured amplitudes, the reserves, etc. It's very interesting. It's very helpful for root cause analysis in the case of malfunctions, or again, for the teach-in process to integrate it into each machine.
And I should mention on that note that if you combine this IO-Link sensor with our IO-Link master, by virtue of a function of our IO-Link masters being offering IoT interfaces, you can get to all of those parameters whenever you want to without even ever having to mess with the PLC program. That's a very strong feature, to be able to get to this information in parallel to the PLC running the process and getting the process data.
Correct. That is an absolute advantage. Just being able to make adjustments without having to shut down a line, without creating downtime, it's a huge advantage.
Good. Sean, I think that pretty much does it. So as you know, there's two things left for us to do. One is for you to come up with a 5-word or so statement that captures the gist of our conversation. And in the meantime, while you think about it, I will try to summarize what I've learned in today's conversation, and you tell me if I missed something, or if you let me go, if I pass the test. So,
sure, give it a shot.
We were talking about an IO-Link double sheet sensor, and double sheet sensors are critical when a process requires assurances that you pull one sheet of material into a process, not 0, not 2 or 3, 1. And the double sheet sensor can detect that. And the strength of IO-Link in this regard is, of course, that we get direct access to every conceivable parameter that could be used to make this sensor fit the application. And the result is that instead of having, I don't know how many we have, 20, 30 of the previous models, we can replace this by a handful of IO-Link double sheet sensors nowadays. On top of that, we have some hardware functionality, mainly the synchronization that allows these devices to be mounted very close to each other. And that gives a user the ability to monitor a material over a very wide range, physically a very wide range as it gets pulled into the machine. So what else? Do you want to add anything?
Yeah, so I would also like to add on to really the location within the application. You mentioned correctly, but you mentioned it's used for validation of the in-feed of material. It can also be used as an after the process to validate that, in the case of cardboard, validate that the laminate is on the backside of the cardboard, for example.
Yeah, very good. Yeah, no, absolutely. Good point. It's not just for before a process takes place that you have the right material. It's also for after a process that these materials were processed properly.
Correct.
And there are no flaws.
Correct.
Very good. I forgot that. Thank you very much. So now it's your time. What is the 5-word or so statement we would like our listeners to walk away from today?
Yeah, so with the iLink double sheet sensors, I'd like to leave everybody with these handful of words that it's, when you think about it, just think about reliable detection of double sheets for most materials. That should summarize just about everything.
Yep, I get it. Reliable because we can make it work with just about anything. Mm-hmm. Double sheet is clear, and we have an incredible range of material that we can monitor.
Exactly.
Well, Sean, thank you very much for your time. This was very, very interesting and instructive. And thanks, everybody, for listening today to Pepperl+Fuchs Plugged In. Bye-bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.